Yeah, so hi Vikram, welcome to the channel. And first of
Hey,
all,
Tejas.
thanks a lot for taking out the time for this.
No problem. Happy to be here.
Yeah, so how are you doing? And uh, for the viewers right here, I think they'd already know you if they're, seeing my channel. But just in case, how would you like to introduce yourself?
Yeah, I can introduce myself for sure. My name is Vikram Shekhar, and I am currently a senior staff engineer at Qualcomm doing device modeling for RF front end devices. So that's what I do now. I also write a RF newsletter on the side at vixnewsletter.com. So these are my two major things that take up all my energy in my day-to-day life. So
Yeah, I mean, the pictures in those newsletters, the visuals are really good. I wonder which app you use for those.
I use Excalibur. It's actually free.
Oh,
It's a
Excalibur. Okay,
yeah,
okay.
excalibur.com, I think. But I use it within the Obsidian editor plugin. So Obsidian is the
Mm-hmm.
text editor I use. Within
Yeah.
that, there's an Excalibur plugin. So I draw everything in that.
Oh,
And
it's pretty
once
good.
you use the tool enough, it kind of you get good at that as well. So
Mm-hmm.
uh,
Yeah.
yeah.
Okay. Yeah, and yeah, congrats because recently your blog got featured, right? Uh, I saw a post by you. It got featured on a website.
Yeah, it was featured on Hacker News front page. Hacker
Yeah,
News is a website where like people upload articles they find interesting, and if enough people find it interesting, it gets like upvoted.
yeah.
So it's like
So
gives a lot of visibility to something like that. So my article on how automotive radar senses
radar. Yeah,
velocity, yeah, that made it to the top. So I'm pretty excited about that. Actually, it's my first article in Hacker
yeah.
News
I mean, I
front
was
page.
surprised because I've been reading your blogs, but the viewers for such articles, technical articles, I think not many people usually take out the time to read such things. So I was actually
Yeah,
surprised that many people are reading this.
Yeah, even I'm
But
surprised. I even thought nobody's going to read RF stuff when I write about it, but nobody was doing it, so I figured I might as well start
yeah,
and see what
yeah,
happens. It's
something
always easy
similar
to
with
just
me.
stop a project if it really doesn't work out. I've stopped many projects before.
Oh,
I'm no stranger to like
I see.
abandoning projects because they don't work out or because they fail for some reason. I figured I'll try this. So far, it's going well. Yeah.
Mhm. Okay. Uh, yeah. So, for the viewers, like, how was your career trajectory? And from, right from your education, how did things progress? How did you, navigate through your career and those sort of things?
Yeah, I can talk about that. So I did my undergraduate in Bangalore in RV College of Engineering. I did it in telecommunications, and after that, I went for my master's and PhD at Texas A&M University. I was
Okay.
primarily going there to do something RF related. At the time, honestly, I really didn't have a clear idea of what I wanted to do. I was kind of open to whatever came my way in a sense at the time. But eventually, I was a analog and mixed signal group there, and I worked with Professor Kamran Entasari,
Mm-hmm.
and my PhD thesis was on tunable MEMS filters and microwave-based sensing, which are seemingly two different things, but I got two different projects that came my way. I found that was quite interesting. So it took me about like 4.5 years to do my PhD. And it was like a very intense PhD. Dr. Entasari is an amazing advisor, and he has like puts the pressure in the right way. At the time, I
Okay.
really didn't appreciate it, but as time has come and as time has gone by, I appreciate more and more what that pressure has done for me. So it was a very productive PhD there, and I got myself like 8 journal papers and 7 conference papers.
Mm.
I kind of got good at writing those papers too, and I
Right.
enjoyed
Yeah.
writing that so much that I figured even now I'm writing technical stuff. So it was a really good experience that I feel like I would do again if I was given a chance. But yeah, the time has changed. Uh, Yeah, apart from that, the PhD has been very helpful, gave me a good career, and it even helped me get my immigration paperwork because I could apply based on the EB1 outstanding researcher quota.
Oh, okay.
And that helped a lot. So it has basically made my life what it is today. So I'm very grateful for that.
Yeah, I mean, you mentioned that you didn't have a clear idea about what you would be working on during your PhD and stuff like that, right? So, what prompted you to actually go for a PhD when, you could have just gone for a, let's say, master's, or maybe not even that? I mean, how did you decide?
So after my bachelor's or undergraduate program, I kind of felt like, I mean, I did all the exams, I did well in the exams and all that, but I feel like I still don't know that much. I felt like I didn't really, I mean, I know a little bit of all these subjects, but I don't really know anything.
Hmm.
And I really liked antennas at the time. Actually, my undergraduate project was more on antenna stuff. So people told me, don't go and do antennas and all that. You're a immigrant there, and you are not going to get a job because all the jobs are going to be defense oriented, and you will not have the clearance to go do it.
Hmm. Hmm.
And
Hmm.
they said you should do digital circuits or something. It'll be better opportunity job wise. And I honestly didn't give it that much thought because I was like, I'm going to go and do it anyway. So the first semester when I went to my master's program, I figured I wanted to do my master's plus PhD in a sense because I wanted to do research. And I
Oh,
felt like
okay.
I'm a big fan of like Richard Feynman and all these people. Like I read all their books and all that. So I was all
Hmm.
enamored by the physicists and all those things. And I'm like, oh, this is really cool. I need to do something. So, electromagnetics and all that was like close to physics for me. So my first
Right.
semester there, I enrolled in electromagnetics, and it was taught by a professor called Dr. Robert Nevels. He was
Okay.
very inspirational, actually. The way he taught equations and the way he made me understand equations was like fantastic. And so I'm like, oh my god, now I'm starting to understand, And he was instrumental too in like me appreciating a lot of RF stuff. So a good teacher takes you a long way.
Definitely, yeah.
And then what happened was how I got into doing MEMS is
Hmm.
kind of a funny story, I'd say. Initially, I was looking at just like joining a microwave lab and figuring out how to make some amplifiers or something like that. But I spent like 6 months in that professor's lab, and it really, I don't know, I still didn't know what I was doing. And we'll come back to this point later.
All
I
right.
felt like I had no direction and all that. Anyway, so I took my professor's class, my thesis
Hmm.
advisor finally, Dr. Entasari. I took his class, and he was an RF MEMS guy. I mean, his PhD was an RF MEMS because his advisor was Dr. Gabriel Ribez, if you've ever heard of him.
Hmm.
He's quite a known figure in the RF and microwave world, actually. So he did RF MEMS, and so in the class project, he said, "Okay, I have a project here that's like a tunable MEMS filter. I'm warning you, it's going to be a pretty challenging one. So before you sign up for it, think a little bit. Who wants to do this project?" And I figured, I'm like, raised my hand immediately, and it was like, oh my god, I need to get this or whatever. And I looked
Hmm.
around me, nobody else put their hand up, so it was just me in the class with my hand up there, like saying me, me, me. But then he's like, "Oh, okay. So it looks like there's only one volunteer for this." And then he said, "Okay, you do it." So the class project was great fun actually because I learned so much doing those tunable filters. And he said, "Well, yeah, you seem to be good at doing this stuff," because he liked what I did project wise. I found it very
Hmm.
interesting, so I got like deep into it and did only that for a long
Just a
time.
second. I
So
mean, so did you have
yeah,
any undergrad research experience, or this was like your first really nice, big experience?
I my undergrad research I would not call very much research. I thought I was doing research but didn't really understand anything I was trying to do.
Okay.
Okay, because I had a project I did at DRDO for my undergraduate, but it was like, I don't know, we designed something that there was no tooling, there were no resources, there was no understanding, and there was no
Hmm.
support from any mentors anywhere. So I'm like, I don't know what I wrote, something I wrote in a book and got out. But so there was no research experience, but I was given a problem, and it's like, okay, now I have to make this project happen, right? Because I have to do it by the end of the class, so I better get it done. So I spent all my time doing that, and it was like, you start to learn. Like everybody starts somewhere, right? And you start to
Yeah,
learn
yeah.
slowly. And he really liked the project and said, hey, you're pretty good at this, like you should be, do more of this stuff. And that's when I asked him, like, hey, how about I become your student instead? Clearly you like my work and I like your subject.
Hmm.
You should do this. And then, yeah, after some discussion we changed advisor, and I changed
How
into his
was the
program.
process, like tough? Because so I have one friend, and he's in a similar, situation right now. He wants to work with another professor, but he's kind of scared that his current professor, might not take it that well.
Yeah, that was actually a concern from, yeah, both me and my thesis
Yeah, yeah,
advisor.
exactly.
But I went and said this nicely. I just said, like, look, I found another topic that has great interest to me with this professor. And my Dr. Entasari was just big starting. Actually, he was just faculty a few years before that, so he was
Oh,
relatively
okay.
new in the university. So I said, yeah, I found this interesting, and I would like to, pursue um, that line of research. Is that okay? And this professor, my first professor, was a very seasoned professor, and he said no problem at all.
Hmm.
Like, yeah, if that's what you like, go ahead.
Okay.
So they are quite understanding, because as a student you're still experimenting, you're looking around, trying to find your way out of it, and it's okay to change like little bit parts and try different stuff. And I don't think you'll upset anybody as long as you handle it nicely. I think it's fine. It depends on how you
Right.
handle it
Okay.
too. Yeah.
Hmm.
Yeah.
Okay.
So that's how I got into basically doing RF MEMS. And then I got my research going in that and tried to find new things to do that can make me papers and such. So, so that was my graduate student life. And after spending time there, and that was great fun because I did a lot of courses and a
Hmm.
lot of research. It was very hard work, but it was worth it. It was nice.
Yeah.
And then when I finished my PhD, it was 2011, and it wasn't the greatest job market actually at the time, considering 2008 is when it all went down.
Hmm.
So I was like, okay. Yeah, so it was not like jobs were like abundant. So I thought about it and I was like, okay, look, like this is like a numbers game. Like I need one job. I don't need five. I just need one, right?
Hmm.
So I'm like, okay, fine. I'm just going to apply to as many as possible. Like, let me see. I don't know, whichever job I get is fine. I'm just going to apply to all of them. So I remember I had a Google Docs spreadsheet, or a document where I used to apply for a job, and I used to copy paste the job description into my Google Doc file because I have to remember what I applied to.
Right,
Because when
right.
somebody calls me back, I need some traceability, how to get uh,
Hmm.
what I applied for. Because if I forget what I applied for, I mean, then they call me back, I'm going to say like, wait, which job is this? That's not a good thing to say. So I should be like aware. So I applied to like 77 jobs. That document became
Oh.
quite big actually.
Hmm.
At the end of it, I got 3 phone calls and 2 on-site interviews, both of which became offers, and I accepted one.
Okay.
And
Hmm.
that was the job I had at Peregrine Semiconductor, which was later bought by Murata and is now
Oh,
called
okay.
P Semi in San
Hmm.
Diego. So that was my first job, and I was focused on basically doing electromagnetics work for RFICs because when
Okay.
you put an inductor and then 2 inductors, or you put a chip on a package, everything
Hmm.
changes, and it's obviously important to capture this. So many companies have specialist electromagnetics people, EM simulation experts.
Hmm.
Most of my PhD, I had a lot of EM simulation work. So
Oh.
that's what I got into. It's relatively new to me. I hadn't done much silicon stuff. I had taped out once in my PhD, uh,
Hmm.
and we'll get to that too. I mean, that's one of the other advantages of a PhD. But yeah, when I went into the company, I had no idea really how ICs work to that extent, because my PhD was like kind of unrelated to it. But
Yeah,
then I
yeah.
had
So
to
this
learn on the
is
job.
like one common, question people say that so if you join right after your bachelor's or even master's versus you join after your PhD, like at least 3 4 5 years of experience. But if you had that same experience in the industry, you might, for that job you might be more well suited, right? Or no, I mean, people are scared of this thing, that the PhD time would not be counted as experience.
Yeah, it probably doesn't. But it's not about experience. It's because if you have a PhD from a reputed university, I think university also matters, right?
Hmm.
Then people look at it differently because they know what kind of trials and tribulations you've been through. They know,
Hmm.
that
Right.
you have handled some pretty hard problems. And especially when it comes to RFIC work, or generally IC work, PhDs are good because you get tape out experience. Very few bachelor's and master's students I have
Hmm.
seen get access to silicon because it's an expensive and limited resource.
Hmm.
When universities use silicon, they would rather see some publications come out of it.
Yeah.
And so the people who need publications most are PhD students. So those are the people who get priority access, I would say, to silicon area. I'm sure there are exceptions to this, but from what I've seen, tape out experience is something that's very helpful, and that's hard to get otherwise. So even if you're losing job experience because you did a PhD, I think there is a different skill set that you are building that is still valuable, and I think the industry sees it as such. uh, Now, if you're going to do a PhD to get extra salary, I don't think that's the way to look at it, but it
Hmm.
does open the door to certain jobs that you may not get otherwise,
Hmm.
just because you have things like tape out experience. You know, and you get very good technically, right? Because you have to solve all these problems and fight through so many issues, because you're
Right.
going to tape out, your chip will not work, you have to figure out why. You have to make something better than what is already out there to be able to publish something. Otherwise, I mean, if you make something that's already there, nobody's going to publish your paper. You have to
Hmm.
be better, right? You have to explain why something is better. So all those things are skills you build, and it gives you a solid background into problem solving, finding out what's new and different, innovation, creativity. So all those things exist.
Okay. Yeah. And like, getting back to the point you mentioned, some of my mentors, they said that there are specialized R&D jobs that only PhDs get the access to. So even if as a master student you wanted to go there, you wouldn't get that job. So.
Yeah, if it is a heavily research oriented position, for sure they would want to know that you come in knowing how to do research,
Hmm.
because that is the experience you get. Experience
Hmm.
on how to do research is important too, and companies do want that, because that's how they make
Right.
differentiated products. They need
Hmm.
thinkers on the job too. They need
Yeah.
thinkers, they need doers. Both are required, and sometimes if it comes together in one package, that's great for them.
Hello.
Yeah, is it okay?
Oh, yeah. 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 Yeah.
Okay.
Yeah. On a lighter note, like during your PhD, how was your life as a, grad student, with limited stipend and all those things?
It
Yeah.
was, yeah, it's, you're not living a rich life. Okay, so it's going to be a student life. Your bank balance doesn't keep growing, or you know,
Hmm.
that's normal. I think you should not be put off by that. Your friends will be in masters. After their masters, if they leave, they will be earning, I don't know, several times or many times your salary, and they'll have fancy cars, they'll have fancy apartments, but you will not have any of that for a long time. So these are all mental battles you will have to fight through. But in terms of stipend, yeah, I mean, all PhD programs give you some kind of a reasonable living wage. I was in Texas, so it's relatively cheaper. I don't know how it is where I am right now, is California. It is much harder, I think, because it's an expensive place.
Yeah.
But Texas was okay to get by. But you're a student, you're busy, you don't worry about these things, so it's
Yeah.
fine.
Yeah.
Comes later.
I mean, yeah. Yeah. True. So, and also there are many people, who just want to, settle abroad, like let's say US, for instance. and so they're not really interested in going for higher studies, but it's like it's a ticket to US or some other place. So that's the reason they go. And so for those people, would you think like it's a wise idea to go for masters, or if their just goal is to settle abroad, they can eventually via a job go abroad?
So that is a hard question because abroad means a lot of places, but the United States immigration has been getting harder and harder and harder. So it's really hard to just settle because even for me, uh, the fact that I had a PhD and not just a PhD with all these published papers really helped my case get on, to get on the outstanding researcher quota, which means it
Hmm.
comes relatively quickly. It's in a year or two. Now that is EB1. Now EB2 is advanced degree quota, which means I think you've got to have at least a master's for that. Even that
Okay.
takes forever now. There is a long waiting period. Like you can check online on these priority dates and all that. It's only
Hmm.
getting longer and longer and longer. So there's this question of immigration. So if you come for a master's, the immigration is still long. I mean, you can settle here. People still work on H1Bs for a very long time without getting permanent residence and all that. But there's this always this element of uncertainty that you feel because
Hmm.
uh, in case layoffs happen, you've got 60 days to find another job, which
Right.
is hard in the time of layoffs. So your so-called settled life might unsettle itself very quickly. So unless you
Hmm.
find a way to get permanent residency, it is not really set in stone. Now, if you
Right.
go straight from, like, say, bachelor's and go and try to get a job abroad, and you don't even have access to EB2, then you will be in the, I think, EB3, which is, I don't know. I mean, it's exponential. These time frames are all exponential. So I'm not saying you should go do a degree just for immigration purposes, but the settling
Yeah.
aspect by working in a foreign country may or may not happen. It happens for some people, it doesn't for some people. And you've only got to try your way. Yeah. I think getting a master's is a good idea from a career point of view. It's
Oh,
not for
okay.
settling or anything,
Hmm.
but I think you will have a better skill set. So even if you were to come to the US and you can't settle for whatever reason and you go back to India, you have a master's and you have some work experience in the US, sets you up to be a better candidate even in India or wherever you go. I think you're a
Hmm.
better resume you have overall.
Yeah.
Really, it does help. But if you can't get it or don't want to or don't have the means, I understand some people are like in those situations. Then it's fine. I mean, if you get a job, take it and see how it goes for you. Right?
Hmm. Yeah. I mean, so now, like, since I'm relatively, new in the industry, I have a couple
Yeah.
of friends so I did a master's right after my bachelor's, but most of my friends, they did not. And now, they're going for masters, mostly abroad and mostly
Yeah.
because they want to go abroad.
Hmm.
So right now, and what we are seeing is that most companies, I might be wrong about this, but it's just an observation that most companies, they're trying to set their base in Southeast Asia, mostly India as well. And they're kind of, getting more jobs here and reducing the number of jobs like in US, for instance.
Yeah. A lot of positions are going to India, which is good. I'm not saying it's not. It's good
Hmm.
for people in India because you
I
get
mean,
more
yeah.
opportunities.
Hmm.
Is it good for US companies? That's debatable.
Hmm.
It's good because they save money on like the cost of an employee, which is much higher here for
Hmm.
various reasons, including health insurance and all that. But long term, I don't know if it's good for a company because they're like offshoring all their businesses. So this is the story of basically Dell and Asus. Dell was
Oh.
like building PCs, right? And then they were like the Asus was is a Chinese company, I think. Yeah. So Dell kept saying like, "Hey, can you make this one part? Can you make
Hmm.
a power connector? Can you make a Ethernet connector?" Then they like,
Hmm.
"Can you make a motherboard?" Then can you put the Ethernet, on the motherboard and things like that. And soon what happened was eventually Asus built PCs and became a competitor to Dell.
Yeah,
So
yeah.
that has happened in the past, and so I don't know if it's a good thing for companies to be doing that. But in the short
I
term,
see.
shareholders
Hmm.
are happy because they get to save money and operational expenses and lower salaries.
Mhm.
And
Yeah.
don't think that's a bad thing. Like many people say, like, oh, you go to the US, you'll get more money and all that. But one
Mm-hmm.
thing to realize is that, yeah, by absolute numbers, yes, it'll be more, but the cost of living is also much higher. So you always have to calculate the delta of like how much you can make in a
I
country,
mean, yeah,
say
but
India for our
the
discussion.
next
This is how much
argument
you
is
spend
that
there versus
you
how
might
much
be
you make in the
saving
US.
percentage-wise the same
Yeah.
amount, but if let's say you return back to India eventually, then when you convert it back, it would be a huge chunk.
True. That's assuming you can save the same percentage. You might save
Yeah.
lesser, and yeah, you might even save lesser.
Hmm.
And the conversion rates might go any which way. So you don't know that you'll actually win out. So yeah,
Hmm.
there are lots of ifs, right? And
Yeah, yeah, yeah.
so what I'm trying to say is that it's not a direct, obvious win to be in a foreign country. There are
Yeah, now it's
lifestyle
not.
adjustments, changes you make.
I mean,
That you stay
like
away
10
from
years ago,
family.
people, I think it was like a clear decision. Now it's like things are changing.
Now things are changing, yeah, especially because there are so many opportunities now that are coming. You know, like Bangalore, for example, is like the Bay Area. Like you go to certain
Yeah,
parts where the tech jobs are, like you can see all the companies there. It's
true.
fantastic, right, to see that. So opportunities are plenty now compared to maybe 10 years ago. So now it's a toss up whether you is really worth going or not. It's not
Hmm.
obvious, I
Yeah.
think.
Yeah, I mean, most people. So when I told them that I decided, so in my case, in India, you have two programs. One is like a bachelor's plus master's integrated program. Others,
Yeah.
my program was a bachelor's, and then I later converted it to a master's. So
Mm.
I don't know. Many people were like, "Why did you convert to a master's? You should have just gone abroad for a master's." And I don't know. They just felt that it was a terrible idea to do it here. But I know I just had a lot of reasons because I thought this was quite good. Not saying this is better or that is better. Both offer different things. But since if I would have gone to US, I would have had to get a job there, like most likely in the start at least. And then I didn't want to really do that. I wanted to be here. So
Yeah, yeah.
that
As I
and
said,
also the
right now I
expenses.
think it's a toss up. Yeah, it's expensive. I mean, you
Yeah.
that's always there. It's a very expensive place. So yeah, it's like a toss up now. There are so many opportunities. There are so many good things there right now. So
Hmm.
either way is fine, I think, at this
Yeah.
point.
Yeah. Okay. So we'll digress from here, and we talked about the industry. And usually here, what I've noticed is in college, people when they think of semiconductors, they think either
Mm,
analog or digital. That's all. I mean, device
mm.
modeling. I don't think anyone even thinks of like device modeling. So just for people who don't know, how would you explain like what is device modeling, and how can someone explore that area as well?
So device modeling, yeah, I think people it's not really taught as a course or anything like that. So I'll explain what it is first. First of all,
Hmm.
when you put a transistor on your schematic in Cadence or PSPI, any Spice simulator, and you hook up a battery and whatever, like resistor and all that, and you simulate it, it gives you an output, amplification or this or that. The
Hmm.
underlying model below that is a fairly complicated model, especially for modern transistors, and they use what are called compact models. So compact
Right.
models are a bunch of equations, and those equations have coefficients. So the device model engineer, like myself, would determine those values of those coefficients that best matches the measured data of the transistor.
Hmm.
And not just DC wise, it has to match in capacitance, in S parameters, in nonlinearity, in everything. So you have to find the best set of parameters to do that. And it has to be kind of physical. I mean, I'm not saying it has to be perfect. There's no
Right.
such
Right.
thing as a perfectly physical model. It has to be reasonably physical. You can't use
Mm.
abnormal and obnoxious values for parameters, because somewhere some simulations is going to not converge or
Mhm.
just explode. So you have to have a sense of what is a realistic value. So that is what a device model is. But what do you need to know before that? You need to know semiconductor device operation physics. What are the non-ideal effects that happen in transistors, and this sort of stuff. So semiconductor physics is where it starts, and I think it's a good thing to know anyway if you are going to do
Mhm.
analog design or digital design, because all of that requires fundamental transistor operation in either, in different forms, of course. But I think it's good to know device physics up to some level
Yeah,
at
yeah,
least,
totally agree
in a
with that.
reasonable
I
way.
mean, at college, I had a course on device modeling as well as compact modeling. There were two courses.
Oh,
And
nice.
so in that compact modeling course, they taught us about the BSIM model. And
Yeah.
I got a experience with most of these parameters that they use. And so, just knowing that later on, now that I design circuits, it kind of helps to see the underlying things that happen. I still don't get the entire, thing, but I have an idea now. So it really helps.
Yeah. So it's good. It's good you had a course, actually. I didn't know they taught it in courses. But yeah, that's pretty much it. I mean, so device modeling is just that. It also involves a lot of measurement stuff. So we go and
Hmm.
measure transistors by themselves. And you have to, it's a small thing, right? I mean, so there's all this, parasitic effects that you have to remove. So there are calculations to do de-embedding and all
Yeah, yeah,
that.
yeah.
And once you remove all that, you get the core transistor. But now you have to trust that your measurement is correct. um, so in general, I like to do my own measurements, and I still do. It's all automated, it's on wafer. But
Hmm.
over the years of doing this many many times, it's a learned skill too, because there are lots of things that you just aren't in books and things like that. So you learn how to make good measurements, and you use that measurement as a target to make device models, and then give it
Okay.
to designers who then use it in their circuits. And if the model is correct, the circuit will be correct, and therefore you can have a successful product.
Yeah.
So therein lies my job, is like try to make a correct model. That's it. Yeah.
Okay. Yeah. I mean, it was nicely and easily explained, I guess. People would get that. And in India, yeah, yeah.
in
So, yeah, go ahead.
No, no, I said in theory it's easy. Yeah, it's
Yeah, yeah. In
people
theory, it's
think
easy.
it is. People think that it's like, oh, it's a bunch of model parameters. You just do some fitting, and then you
No,
get a
that's
value. How hard can that be? But the problem is the BSIM model has like 300, 400 parameters. That's
yeah,
a
yeah.
lot of. You can see how many dimensions there are, and these are continuously variable numbers, right? So it takes experience to make a good model. That's what it is. Yeah.
Hmm. Right, right. I mean, so my master's thesis was in device modeling. I did it on cryogenic low temperature modeling of this bulk MOSFETs. So I remember, so in during my thesis, there was a time when we were trying to fit I devised some physical model. There were no empirical parameters in it. And then I decided to just hook up one empirical parameter, so that I can vary the and fit the
Yeah.
data somehow. But my advisor, he was like, no, we have to be fully physical. And then it was really challenging. And then, yeah, but it helped to expose some, problems with the model. And later on, I was able to solve those. So it was a good experience, I'd say.
Yeah. It's a good thing to have for sure. Should try it. Everyone should try making a model once.
Yeah, yeah, yeah. And so the thing is, in India, I guess there are jobs in device modeling, but they are pretty few compared to analog or RF or digital. And I guess that is so. First of all, there are a bunch of software jobs. Just forget about semiconductors. So most people, even if they're remotely interested in semiconductors, they'll just gravitate towards the software jobs because they're abundantly available. Next, those who come to semiconductors, they would either go for analog or digital because they are more in number, and just the probability of getting into those is higher. And then those who are really interested or passionate or aren't scared about finding a job, they just want to learn. They'll actually go for devices and stuff like that. That's what I've noticed. So, by the way,
Yeah, that's
what do
true.
you?
Sorry, I was going to say, I always joke that, for every 10 software engineers, there is one hardware engineer. and for every 10 hardware engineers, there is one analog RF engineer. Because even digital engineers are more than RF
Yeah, yeah,
analog
yeah.
guys.
Correct.
There are so few. Yeah.
Mm-hmm. Yeah, that's true. And I don't know, when I was in college, I never really liked the idea of digital. I mean, I so I like to learn about it, but as a job, I just thought that it's too much of coding. It's not exactly coding, but analog felt more intuitive for me. I don't know.
Yeah. I mean, that's where preferences come, right? We need all
Yeah,
of them. We need both digital and analog designers. So some people have to do digital too. So I'm glad there are people who like that too.
yeah, yeah. By the way, do you think that in the future, the semiconductor market going up might, somehow become how software is right now? Like people would start thinking about semiconductors first.
It used to be that way before software even became a
Oh,
thing, because like the semiconductors came earlier, right? Only software came
yeah,
after
yeah.
all that. Semiconductor was the original, and it came out of research and physicists and all that initially. Anyway, from Bell Labs and all that. But I don't know if it'll flip like that, because the applications of semiconductors, like this software, I mean, even with the rise of AI and all that, the number of things you can do with software is much, much more than what you can do.
Hmm.
And not to knock on any software engineers, I'm pretty sure it's also a very challenging job in its own regard. But all this hardware engineering stuff is like, it's difficult to learn. I don't know how else to put it. It's a lot of physics, it's a lot of math.
The
There are
barrier to
no
entry is
good
higher.
barrier to, exactly, well put.
Yeah.
Yeah, the barrier to entry is quite high.
Hmm.
You don't have good resources. Like if I want to learn JavaScript today, I can find
Yeah.
YouTube tutorials, like insanely good ones. But
Yeah.
if I have to learn analog circuits, I have to go to Tejas's YouTube
Oh.
channel and learn from yours, right? I'm glad you're doing this, by the way, because somebody needs to like also put this kind of content out there, and I'm glad you're doing it, because there is no other way to learn. Like most people who learn stuff, who have the experience, don't really go out and teach. There is
Yeah.
no concept of open source in hardware. I mean, they try to do open source in like
Hmm.
PDKs and this in process
Yeah.
technologies
Yeah.
and all that. Like there are some open global foundries 130 or sky water or
Skywater.
something. Anyway,
Hmm.
yeah, but they're not really sophisticated. It's not even close to what an industry standard PDK looks like. It's not even remotely close to it. The tooling is
Yeah.
so bad. All this is a problem, right? But the software industry is so open about teaching each other a lot of things. Like open source projects exist.
Hmm.
Even big companies like Google open source major projects like TensorFlow, and things like that.
Right.
And so it is so much interaction in between the community in software engineering. It's really easy to learn, and the barrier of entry is much lower. It is the same line of thought which occurred to me, like it occurred to you, to make YouTube channel, to and make videos about electronics. That I looked at a lot of Substack publications and all the software people teaching each other how to do various
Yeah.
things, and how does Netflix give you so many videos on your TV. Here's their stack, and I learned that from this newsletter called Byte Go, and I was like, this is so interesting. Where do I learn hardware stuff? There's nothing out there. So I'm like, okay, fine. Let me just start one. There may not
Hmm.
be much of a market, so basically this is the same thought process I had, and said like, okay, I better start doing something, writing something online, because maybe people will get inspired and also start something, because there's only this much I know. There's a world of electronics and hardware is so vast. It's like I cannot cover it by any means. Similarly
Hmm.
for you, I suppose, right? I mean, you teach an analog electronics, and it's nice to see that.
For me, it's
It's
even, for you, I mean, you still have a couple of years of experience on under your belt, right? For me, the thought was that, people will just criticize key, get some experience first, then teach. What are you even telling us? And all those things.
No, it's good you started actually. That is, you've successfully managed to overcome imposter syndrome. Because it's not
Yeah.
like you don't know, like you still know more than somebody who's like a year or two behind you, and
Mhm.
that is enough to teach people. You don't have to become the absolute expert to start doing anything. I think this is the misconception that's holding everybody back. Like, I don't
Yeah.
know a lot of stuff either. Like, a lot of stuff I learn as I go, and then I write about it. So I have just
Right.
learned a lot of these things last week, and I am writing to people who will probably read it and have worked in the field for like 20 years.
Hmm.
And sometimes they correct me. I'm okay
Yeah.
with that. Just like, it's fine. So I think that should not be something holding people back from teaching other people, right? So at any
Right.
level, people can teach, and there's something to teach somebody all the time.
Right. And if people think this way, then no one's that absolute know-it-all guy, right? Then there'll be no teachers.
Exactly. I mean, exactly. There's no absolute know it all either. So there is no threshold after which you're suddenly
Yeah. Yeah.
qualified
Yeah.
to teach. Yeah.
Exactly. Hmm. Yeah. Nice. So yeah, I mean, you mentioned the lack of resources. I totally agree with that one. Especially so in RF, usually there's a really good book by Professor Razavi, RF
Yeah.
Microelectronics. I
Yeah.
mean, to just get a basic understanding and all, I think it's really good. Especially there's a introductory chapter on all the jargon. Uh,
Yeah.
so
Yeah.
that's quite good. But other than that, how would for someone, let's say their university or undergrad school doesn't really have much of RF work. So how can they, learn online or just educate themselves?
That's a great question. I have also been asking the same question to myself. I don't know if I have an exact answer. You know why? Because
Hmm.
uh, I think that you have to go read these books, and they are hard to understand. For somebody who has not
Yeah,
read
yeah,
this,
for sure.
it is hard to start with the book, textbook. The other only approach that is available is that you have to go to university and sit in a classroom and have a professor teach you. These are literally the only two ways. Now, there
Hmm.
could be a third way of taking online courses. However, some do exist, like Rasoft, RAHSOFT, is a website that does have some courses. So, but there aren't that many. I'm not saying I haven't actually done one of those courses to find
Hmm.
out whether I can't comment on it at all. But there are a few online resources for courses, but otherwise you're pretty much left to fend for yourself. There is no resource, right?
Hmm. Hmm.
That is why between the textbook, which is tutors, and university, which costs money and time and all that to go to, and you may not get admissions, there's so many factors that will stop you from going to university. We need something in between. So you having a YouTube channel, and there are a few other YouTube channels that are nice, like
Hmm.
Anurag Bhargava's ADS
Yeah, yeah.
Keysight channel is very nice for RF stuff, and I'm sure there are a few more uh, good
Hmm.
resources. Uh, I have a newsletter that explains some stuff. I hope to
That's
build
quite
up
good.
that
Yeah.
library. Yeah,
How do
and
you, I mean, sorry to interject, but how do
yeah.
you, manage your time with your job and your newsletter? Like, how do you, is there a schedule
Oh,
that you've set?
yeah. That's very difficult. It's actually very difficult to do because sometimes the job takes over, and not only job, like family time takes over too,
Hmm.
and that means I have to be very disciplined in getting this done. I had a schedule going for a good 4 or 5 months that I used to get up at 4:30 in the morning before everybody is
Oh.
up. And last night, before sleeping, I would have made a bullet point list of what I'm going to do or read or write. And I just, when I get up in the morning, there's no thinking. I get a cup of coffee and I start working on it. So from 4:30 to 6, I can get some time to myself. After which the
Hmm.
day begins, like the family is up and this and that and all that. It's over. And s- what happens is the day goes by and all that, and then in the evening I get some time again. So a newsletter takes me anywhere between 10 to 15 hours to write, and so if you break that up, it into at least the working days, if I can put in a couple of hours a day, I get 10 hours in a week, Monday through Friday. by doing
Oh,
12 hours a
okay.
day.
I see.
And then it never happens. So sometimes it goes into Saturday, and sometimes even Sunday. But then,
Hmm.
luckily, what has happened is the more I write, the better I get at writing. So it takes me
Yeah.
lesser time to do future things. So that in the beginning it was very difficult, but it gets
Yeah.
easier with time.
Yeah, I mean the writing part, yes, but since this is like a technical field, I mean you constantly have to educate yourself as well, research about, new
Yeah,
topics, and let's say you're trying to write something, you'd want to dive deeper into it yourself before, telling it to the world. So that would
yeah.
take up a big chunk of time, just to research about what's going on.
Yeah, yeah, yeah. It takes time. So, what happens is that I have a way of reading that is kind of developed over time. I don't really read in depth everything, right? I don't uh, try to do it like I'm studying for an exam. I just glance through
Hmm.
it, and I glance through this, I glance through that, I open this textbook, I open that. And then a story starts to emerge in my head like, okay, I have to explain this idea first, and then I have to explain that idea first. Then I can connect it to this, and I try to go for like 2000 words, which is 10 minutes of reading, which is what I promised in the newsletter that I won't take more than 10 minutes of your reading time per week.
Yeah.
So I try to limit that to that. So once that idea forms, then I can go into in depth and flesh out each section nicely by the end of the week. And then I spend maybe 3 hours drawing all those pictures.
Yeah, I
Yeah.
mean, it's since I also do not a newsletter, but I make videos, I kind of know how
Videos.
it's not that simple as it seems. I mean, it looks quite easy that if you know the topic, you just have to, speak it out, but it's not that easy.
It's not that easy at all. When you have to put a coherent thought to somebody else to
Right.
understand it, it is a problem. And if
Hmm.
anybody listening to this feels otherwise, they should try it. Just try making a
Yeah.
video. Yeah, just try explaining something in on front of a camera. It's pretty hard. Yeah.
Yeah. And especially when those things would be out there, permanently, you can't, there's no room for error or something.
Yeah, I don't. I mean, you should not worry about that too much. I mean, you try to convince yourself first. Like, if you are convinced that you understand, I mean, they don't. If you fool yourself, you're going to fool other people. So
Hmm.
you should
Yeah,
not
yeah,
say
yeah.
anything you don't believe in.
Right.
So whatever you're making a video or writing about, you should first believe in it, that you understand it. That may be you may have a mistake in that, and that's okay, and which you correct it at some point, and that's a good learning opportunity to make another video saying what you got wrong about it, and how and why it is not that way. It's more
Hmm.
content really, but it's okay to
Yeah.
be wrong. I don't worry
Yeah.
about that stuff.
Yeah, I mean, the only thing is that others, someone who's new to the field, that person might be misled. So that's the worry.
Yeah, I mean, hopefully if you're honest enough with yourself, you will not mislead anybody.
Yeah, yeah. Yeah, that's pretty much it. I mean, we covered a lot of topics, and uh, just a final, piece of advice. Do you have anything for the viewers? Since most of my viewers are quite young, I mean, just in their 20s.
Yeah, I'd say that you should find a way to continuously keep learning. If there's one thing I have seen, it's that people feel like once they are done with a degree or a university or they found a job, that defines a boundary between where you stop learning and now you are start doing. There is no such thing. The
Right.
learning continues throughout. Think of it as like an undercurrent to everything, and you are going to keep doing your job. Uh, Using the learning you've had in the past and using the learning you're continuing to have now, and always find an opportunity to learn something new. And it's easy. The easy trick to do that is simply ask why. No, keep asking enough whys and you'll get to the bottom of something you don't understand within about three whys, and there is
Hmm.
your learning opportunity. So keep that going no matter how much in life that you go, because there's so much to learn. Because that's one thing I learned after working in industry this long, is that the more I work, the more I have done all these degrees, the more I have understood that I don't know anything. Like there's still
Yeah,
so much to
yeah.
learn and so much to do. And if you keep learning stuff, you keep staying excited, and your job need not become something extremely boring, because the
Yeah,
onus
I
is on
agree.
you to be interested in a job, because it may get boring with time. When you join a job, it's interesting. Maybe first 1 year it's all new to you. 2 years, 3 years goes by, 5 years goes by, and now you're like, it's the same thing. I'm doing the same thing. But that attitude, you cannot look forward to an employer to give you the learning opportunity. You have it all
Mm,
the time. You have to
yeah,
capitalize on it.
that's a really nice, mindset. Right. Yep. I mean, good piece of advice. So it was great talking to you, Vikram. Hope to stay in
Yeah,
touch.
likewise. Yes, absolutely. Keep up with the good work on your YouTube channel. I look forward to seeing more videos.
Yeah, thanks. Yeah. All right, then I'll end the call.
Okay. Thanks for
Yeah.
having me.